Question 2. The time of flight TOF mass spectrometry can be used. Mass spectrometry can be used to analyze large molecules such as the pentapeptide leucine encephalin. P is ionized by electrospirit ionization, and its mass spectrum is shown in figure 2. Abundance, MZ value. Describe process of electrospirit ionization. Okay, so electrospirit ionization. Well, P, electrospray ionization. Well, we know P is dissolved in a solvent, injected through a nozzle at high voltage, gains a proton. So, electrospirit ionization, P is dissolved, put in, added to a solvent, injected through nozzle, dissolved, probably should. P is dissolved, or we can say P is dissolved or put in a solvent or added to a solvent, injected through a nozzle at high voltage, gains a proton, and then give an equation to represent ionization of P in this process. Well, it's going to gain a proton, so it's going to be P proton H plus P H plus P plus H plus arrow pH plus. Then it says, what is the relative molecular mass of P? Now if you look at here, we've got, oh, this is a very sneaky question, and you know it is very sneaky, because we know here it says the MZ value is 556. Yeah, that's 556. And this is when it's ionized by electrospirit ionization. So this is with the plus H plus. So therefore, to find the relative molecular mass of P, not the electrospirit ionization, just relative molecular mass of P, it's just going to be this value minus the proton, so minus 1. So it's just going to be 556 minus that H plus minus 1, 555. So therefore the answer is 555. And then 2.3, a molecule Q is ionized by electron impact in the TOF time of flight mass spectrometer. The Q plus ion has the kinetic energy of that ion takes that long to reach the detector. Length is that long. Calculate relative molecular mass of Q. Okay, so how do we find a relative molecular mass of Q? Okay, there's a reason they've given us Avogadro's constant. Usually when they give us Avogadro's constant, they said it's previously before, not my old videos which are deleted now, but usually when they give you Avogadro's constant L, they want you to use it. So what we're going to have to work out is a mass, and then we're going to times it by L to get the molecular mass of Q. So first things first, how would we find the mass of Q? So first things first, we need to find mass of Q. Now, we need to find well, we've got the length of the tube, which is the same. We need to know the velocity. Velocity is equal to distance over time. Velocity is equal to distance 1.50 over time. So it's going to be 1.50 all over 1.23 times by 10 to the power minus 5. 121951.2195 meters per second to the power minus 1. So we get that. Now we can quite easily find the mass. So we already know KE. We know KE is equal to a half mv squared. So you can either learn these by heart, the rearranged equations, or you can rearrange it in the exam. However, you are going to waste precious time. So we're trying to find m. Well, we're going to tan by 2. We'll get curly arrows. We get 2ke equals mv squared. M equals 2ke over v squared. So m is equal to 2 times by ke, kinetic energy, 2.09 times by 10 to the power minus 15, all over velocity squared, this number squared. And I can just draw an arrow to here. Well, in the exam, probably just write it. So let's just put this in a calculator now. And we get